Alright, now that we have so that the character can collide with things moving to the left or to the right, let's add some gravity and stop him from falling through the ground. So let's go up to where we said we were going to add gravity, which is in update, just before we slow down the character's horizontal position. This is very simple. If the velocity is less than the maximum falling speed, which we'll have to add to our constants, then we'll add some gravity, which we'll also have to add to our constants. So let's go up to our constants, and right between these two we'll add the constants float, gravity, and 0.25 is what I said I liked using before, and max fall speed will be 20, which is pretty quick. So let's go over to monsters here, and we'll copy those constants into here while we remember. We'll give it a max jump to something similar, say -12. Okay, so we're moving down. So initially we'll just assume that grounded equals false, and then we'll determine in here whether he actually is on the ground or not, and then we can use that later to determine whether he's allowed to jump, because he can't jump off of thin air. Offset y 0, and we'll use that offset if he's on slightly different terrain, like if he's on the spikes or something. For now though, we'll just concentrate on making sure he doesn't fall through basic tiles. If he's actually in a tile that you can stand on, then we got to fix that. So let's do that first. So considering his Y position plus the player offset of his feet, so that's kind of what we're concerned with. Is it going to go through the tile or is it in the tile? If it's greater than the Y position times 64, which is in world coordinates, plus our offset Y, which is going to be 0, because this is not irregular terrain. Are his feet somewhere within the tile? If they are, then we'll say position Y of the character should be Y times 64, which is the top of the tile, minus the distance between the root bone of the player and the player's feet. So that would be, that distance is the player feet offset. So that'll move him up so that his feet are touching the top of that tile. And we'll just put plus off Y. Actually, to make this less confusing, let's not use offsets yet. This is the case. We'll just make sure velocity.y is set to 0, so he's not falling anymore. Grounded is true. And also we'll have to handle the case that he landed on a spring. We'll do that later. In the case that the tile below him, the x, y plus 1, is something that can be that you can stand on, we'll do the same kind of check for that. So let's just copy this out of here and paste it right into here. And it's the same sort of thing if position plus the feet offset. This time, if it's greater than y plus 1 times 64, that'll be the world coordinate of the top of the tile below him. Then we're going to say the position will be set to y plus 1 times 64 minus the feet offset. And that'll work okay. Let's test it. And right now, it kind of pops up because he's going right into this one. And that's actually not undesirable behavior. And this will bounce you up as soon as you step into it. And it freezes when I hit down, so there's something wrong with that. I'll have to fix that. So what that looked like was an infinite loop of some kind, and it seemed to be triggered by when he tries to stand up, which tries to play a reverse animation. So let's check our reverse animation in our Mal player and see if we did something wrong. So if it's infinitely looping, it's probably not playing it in reverse correctly. Oh yeah, if the timer is less than t1, so it's counting backwards, whereas here it's got to be greater than t2, so going in reverse. But if it's always adding, it's never going to reach that. So let's change this to minus and see if that helps. Yep, now he can duck. And you'll notice that you can start ducking and go right back up right away. That works fine. So let's go back up to our update and go to idle and allow jumping. Just uncomment what we added there before. And we can't jump when we're in duck mode. We can jump when we're in walk mode. Let's go ahead and add that hero jump method. Let's go up here. So we can start a private method for hero jump. And we can always change it later if we need it to be public. And so if the hero's already jumping, then we don't have to do anything. So we'll return. It might be that he's in the process of landing, or he's in the air, and he just became grounded. So let's make sure that he's just started jumping. So if he's already started, and he's in the start process, then we don't want to bother with setting up the hero jump. So to begin with, we'll set the jump mode to start. That's sort of that anticipation part of the animation. Grounded is false because he's coming off the ground now. And here we're going to play our jump sound. And we'll add that later. Okay, and so the gravity should take care of making him fall again. Now let's add to our finite state machine a jump state that we'll take care of in here. So we'll add a case for motion.jump. So if we weren't jumping yet, last hero motion, we'll want to make sure that it's been initialized. So as long as there's been at least one cycle where motion has been set to motion.jump, then we can go ahead and start our jump stuff. So let's just make sure our animation's started before we tinker with the animation. And we'll say if key 1 is less than 2, so it's in that starting of the animation for the jump, then we'll set the play speed to an ideal speed. And you may have to play around with your play speed to get the anticipation to look right. It's going to play at 4F. Instead of 70% play speed, we want the starting animation for the jump or the anticipation to be actually rather quick so that he can jump out of the way very quickly. For the other keyframes though, we'll set the play speed to be 50%. So as he's moving through the air, it slowly animates the jump animation because he'll probably be in the air for a little while. And in the start of the animation, he doesn't actually lift off the ground yet. We're starting at key 0. When we reach key 1, we know that's where he starts to come off the ground. So we can set his velocity there. So when key 1 equals 1, and this will depend on how you've set up the keys for your character animation for your jump. I have it so that at key 1, he's coming off the ground. So we can set him as being in the air. And the jump mode should be jump state.start. Then we'll say the jump mode is, because it might still be on key 1, but we've just changed the jump state now, so that's why we have to put jump mode equals jump state.start to make sure that we haven't transitioned already to jump state.air. So now he's in the air, and the velocity y, his upward velocity, is going to be max jump speed. So that's how fast he starts off at jumping upward. So we'll say leaving the ground. If the animation finishes, is animation done? Then we'll say the hero motion is going to set to the idle. Let's go back to that, and then it'll decide from there if it should change to something else. Okay, and we'll also need if he's going left or right. Yeah, we'll need to accelerate him in those directions, but we won't change the animation. So if the input key down keys.right, gotta remember flip is false to begin with, in case it was actually true. And if our velocity is less than max velocity, then we're allowed to add to our velocity. So we'll say velocity.x plus equals 0. We'll say 80% when he's in the air. Accelerate right. Let's copy that. Same sort of thing for left, except that flip is going to be true because he's facing the other way. And if this is greater than negative max velocity, then we can go the other direction. Accelerate left. Let's test what we got so far. Oh, I must have made an error. Just add an extra bracket here. Or actually, we could take out some of these. There, not as messy. Okay, let's try that. Okay, he won't jump, so we must have missed something. Oh yeah, we set the jump mode, but we didn't set the motion, so we definitely want to remember to do that. Hero jump equals motion.jump, and hopefully that does the trick. Hero jump, hero motion, not hero jump. Let's try that. Okay, now he can jump. The animation looks pretty good. And what you can have it do too is just kind of, if to make his ears flap or something as he keeps falling, you can have it so that it loops a section, you know, between keyframe 5 and 6 or 2 and 3 or whatever your final keyframes are for your animation, for your character. So if you have the hair flapping in the wind or whatever as they fall down, you can keep it looping as he's going down. And then when it reaches those desired keyframes, or when it reaches the ground, you can actually have it do an exit for the play, an exit sequence. So when he hits the ground, it'll continue to play an animation for the jump, even though he has ground status. And that might be from keyframe 5 to 6, depending on your animation. So the way his landing looks. We're just going to keep this one simple though. Okay, so I paused it just to fix something here. I'll show you exactly what I did. Before we were saying else if, and then checking to see if the user input was one of the jump buttons, and then saying if the character is either grounded or got hurt, then we're going to allow the hero to jump. And we end up copying this and pasting it into all these different states. And I thought, well, here's an opportunity for me to just take this and just put it in the hero jump and tell it to check for input. So if you're unfamiliar with C#, this would be the same thing as just saying true. By putting check input here, colon, it just makes it obvious which parameter we're setting, and it makes it more obvious when we read this part of the code that that's what we're doing. We're not just triggering hero jump, we're actually checking the input to make sure that we can do a hero jump. So by default it would be false. So like if he hits a bouncer or something that sends him flying upwards, it might set its own velocity before it triggers hero jump, and by default it wouldn't be checking for input. So first it makes sure that it returns if the hero is already jumping and it's the start of a jump, because we don't want to re-trigger the jump at the very beginning of a jump. Then if the check input is true, we see if they pressed one of the buttons to trigger the jump. If not, we just return. And if the character is not in a state where it's allowed to jump, such as grounded, or if he landed on some spikes and got hurt or something, then we return. So if he's in the air, not grounded, whatever, then we just return. So I commented out these lines, replaced it with this, and this does its if in here for whether the jump button was pressed or not. I also inserted a hero jump option into jump itself so that you can re-trigger the jump if you jump up in the air and you're in midair and your feet just start to touch a platform. This will allow you to jump immediately off of that. But in order for that to work, we got to allow other keyframes. So if it's the beginning of the animation, the key 1 will be less than 1. However, if before we said that when it equals 1, we've reached the point where he can jump and his status will be in the air, and then we'll set the velocity for the jump. And that, the key thing to remember is that's if he's in start mode, and this is going to change it to air mode. But what if we're in air mode and this is not equal to 1, but we want him to be able to jump? So by saying greater than equal to 1, so long as he's not in start mode, we're going to allow the re-trigger of a jump, which will put him back into start mode, and then you can't re-trigger the jump instantaneously after that. It'll have to wait until he's at least beyond that start mode. The way it was working before is when he'd jump, he'd land on the platform and it would force it to finish the animation before it would allow jumping again. So it would finish that jump animation. If you're trying to hit jump right away, there'd be a slight delay. But now you can jump instantly. So I'll just take these out. It's a little less code to look at in all these different states, occupies less space, and it's easy to read and understand what it's doing. The next thing we'll notice here is that if he's not exactly on the platform, we want him to not fall off to the edge of the platform, basically. So that's undesirable behavior, because the player's going to get really frustrated if they go to jump off something and all of a sudden, or they go to make a long jump and they're edging up to how far they think they can go, and all of a sudden the character falls through the platform, for example right here. So we'll want it to check down to the right and down to the left also, and see how far horizontally he's moved over, and decide based on that whether he should actually fall or not. Now go down to where it says moving down in world collisions. Right now we have it so that if he's in a tile, then he won't fall through it and it'll push him back up so that he's standing on it. And if he's on a tile, it won't allow him to fall through it, and it'll make sure he's in the right location relative to where his feet are. So we also need to check the situation where it thinks that the tile is now to the left of him and he could be partly on that tile. We'll say if his position, we can copy actually from here. Actually, we could use the in the tile version, and then we'll do the on the tile version after. So same sort of thing as these two here. We're doing an in the tile version, checking the tile to the left. If the feet are greater than that tile, let's find out if that's going to be a problem or not. How far has he moved over horizontally? So where's his X position relative to that tile? So it's got to be less than a certain amount. So we know it's at X minus 1 location times 64s. So that gets its world position. And we know that it's 64 wide. So we're going to add 64 plus about 20 pixels based on how wide the character is. So I'm just going to hard code this time. You could put in a constant or a dynamic variable based on your character or have it use a rescale factor. I'm just going to hard code it as 84, but like I said, you'll have to keep in mind that this is hard coded for this character, and for your own projects you might want that to be dynamic, might want it to be rescaled. You'd use a variable for that. So we're going to place like before. Actually, we can just copy right out of here. There. Now we can move on to the next situation, which would be almost identical. Just going to copy and paste it. Then, I mean, technically you could probably find ways of reusing code and getting rid of this extra code, but I don't think this is a big deal, and I think doing that would actually add more complexity rather than reduce it. In this situation, we just have to change this to y plus 1, and then this would have to be y plus 1, because that's the tile we're concerned with. This is the tile under us, under and to the left. Okay, and let's do the same thing, except to the right. So I'm just going to copy this over, concerning ourselves with the one to the right and underneath of us. And the only thing that's different in this one is we're going to say plus 1 times 64. And we want to check 20 pixels, so we'll say minus 20. So that is the center of the character. If it were on the edge of the tile, and we're going to allow him to be 20 to the left of it. Oh yeah, definitely change this to greater than. If his X position is greater than that side of the tile minus 20 pixels, then it's possible for him to be standing on, which means that we can just do this like before. And we can copy this version where he's kind of in the tile to the left of him. So we'll check if he's kind of in the tile to the right. Changes to plus 1, changes to greater than plus 1 minus 20, and then just set his offset. So let's see if that works a little more accurately. Yep. Yeah, that's exactly what we want. So now you can edge right up to the edge, and you have to actually be off the edge before you fall off. That'll give the user a little bit more control and a little bit more confidence in your collision detection. And let's make sure that his head doesn't go through things that are above him when he jumps up. So we'll check above us, and we'll see if we're starting to go into a solid tile above us. Oops, I got a bracket here that doesn't belong here. If position y minus the player's head offset, so the top of his head is less than y times 64. The thing to remember is that the tile occupation of the player is sort of around where his feet are. The tile above that is y minus 1, which is where his head is. So y minus 1 is not actually above his head. So we're actually testing to see if he's actually in that tile. So if position y minus the player's head offset is less than the top of that tile, then that means that his head is pushing into the bottom of a solid tile. You might have to stop and think about that and visualize it. In this case, let's just set the velocity y as 0 and prevent him from going through that tile. We'll retain the original position. If, checking for the one to the left, we'll do the same sort of thing there, and we'll do the same sort of thing for the one to the right. Oops. Let's keep it as simple as possible and tweak it as we need. So let's test this out. Tip of his head goes through the block, which is fine. It seems his ear catches on it, so we may have to factor in some offsets. So we'll just scroll down to our moving down section where we have the x minus 1y, and look for this and copy that for our x minus 1 and go back up to our moving up. And for x minus 1, we'll go inside here and say we can do this in this situation. And the same thing for the x plus 1. We'll just copy it from down here for the horizontal offset check and go to the x plus 1 and paste that test here. Now we'll test it out in the more accurate version. So now the edge of his head can go up through it, but if he's too far under it, then the top of his head will actually hit the tile. And that's exactly what we want. He does catch on the tiles above him sometimes, which is okay, but we might want to prevent it from doing that. So what's happening is it has a lot of tolerance for allowing the head to overlap underneath of an object, but then when move right and move left check it, their tolerance aren't as great because they don't factor in that offset. So we could factor in a vertical offset for the move right and move left, but just to make things simpler, we're just going to give it more, or we're going to give it less tolerance for the head so that it'll actually hit where his head is. So instead of a 51 pixel difference from the root bone, we're going to say 71. So the collision area isn't so far down into his head. It'll be further up from the root bone. And at 71, that's more than 64 pixels. So his head will definitely not catch on anything now. And in fact, actually, that looks a little better. He's not going quite as far up into the tiles. Looks a lot more accurate. Okay. Scroll down to where it says World Collisions and keep going down until you get to moving down. We're going to add a response here if we hit a spring. So where it says if spring, say if tiles x, y type is a spring, we'll set the starting velocity to be the bounce velocity. We'll activate a bouncer at that position using the bounce manager. So add x, y to add the bounce event for that tile, and we'll call hero jump, and that'll be a reaction to the spring platform. We can copy that and go to the next one and just change the y to y+1, and also for the bounce manager.add y+1. And we can continue to do that for the ones after. This one would be x-1. Although I don't think we should do it for x-1. I want to make sure that he's sort of in the center of the leaves before it allows him to spring upward. So let's actually remove that here, and we'll remove the comment from this one too for springs. So yeah, just for x, y and x, y+1. Okay, and we'll go over to the other ones and try it out there. And from below, yeah, it works fine. Just pausing for a moment there to show you that in editor we actually have a bug for when you save the level. This should say tiles high, not tiles wide. The other thing we need to do in editor is go to load level, and where it says set player's position, we'll put player position. Wait, do we have access to the player yet? Nope. So we got to fix that first. At the top of editor, after input, we'll put player. And then in our constructor, we'll put player here so we can pass it in, and then we'll have access to it. Right after input here, we'll put player equals player. Okay, now let's go down in update for editor where it says place player. Let's make sure it actually places the player so that we can test it right away. And what world coordinate here is, it's just the tile converted into world coordinates, and then with an offset added to it so that the player position is kind of positioned around it better. So let's go down to load level. And right here we got the map coordinate where the player starts. So we'll have to convert it into world coordinates. You can use tile to world again, and then use that location, and give it an offset. And we'll also have to go into game 1, make sure that we pass the player in. You'll see right away editor is underlined, so we'll just add player. Oh, player comes before sheet, so player goes here. Right now, if he lands on spikes, he's standing right on the very tips of them, almost floating. We'd like to make an offset so that he's partly down into them, and make him react with an ouch animation. So let's do that next. In our player class, let's set a global. I'll put it right by world collisions because that's the only place we're going to use it. On spikes, at least for now, that's the only place we'll use it. Actually, no, that might not be true. So then scroll down to where it says move down, moving down, and we're going to take advantage of this offset Y thing here. Before we do anything though, let's set on spikes to be false. And then right before we do our check to see if he's colliding with something, let's find out if the tile is spikes. So if this tile is spikes, we'll set the offset Y to be about 28 pixels down. Otherwise, we'll just make sure that it's 0. And what we can do is add that offset Y into here so that he has to be greater than this position plus that offset. So when we're adjusting his position, we also have to add in the offset. So if it's not 0, then if the offset y is 28, which is what we set it to here, then we know that onSpikes is true, because we passed this test and we passed this test. Rather than testing both again, we can just say if the offset's 28, onSpikes is true. So we can copy that behavior from here to here, just change this to +1, add in the offset y here, as well as here, and then just copy this into here. And we'll do the same down here. Right after grounded, we'll just paste that in there. We can do that for each one of these. And then we'll copy this line again. So this one will be for x minus 1 and y. And let's just copy this down and change it so that it's matching each one based on what tile it is. +1. This one's +1 and +1. This one's just +1 for the x. We'll go back up to the x minus 1, we'll add in the plus off y, and we'll add that into adjusting the feet. For the position check and the feet adjustment for each one. And testing that, you can see that the offset is right. When it does horizontal checks though, it's not allowing you to walk through the spikes, except for right near the edge. That might be desirable, but we might also want to be able to run out of the spikes or jump out of the spikes. Well, we can jump already, but somebody might want to be able to run out of the spikes, and that might frustrate them, so you might want to change that. If we do want them to be able to walk across the spikes, what I would suggest doing is what I already did here. I'll just do the same sort of thing here. If the character is on the spikes, then we'll do the check. And the tiles, x minus 1 in this case, and y minus 1 is spikes, dot spikes. Don't use dot type. Then we don't do anything. But otherwise, we'll do else and 2 curly brackets and this section here. Can't walk right yet though. We've got to apply the same logic. We can copy this logic up into here and just modify it for the other way. So this would be +1 and y, and a couple of curly brackets around this whole thing. And this one would be x plus 1 and y minus 1. So now while we're on the spikes, we should be able to walk through them. Oh, can't walk right yet. Must have a bug. Okay, turns out it was the dumbest bug ever. I didn't put an else here. These were just curly brackets. So else is important. So now he can walk on the spikes, even though he's getting hurt.